we have taken up to explain the concept of conservation of energy in electrostatics. Right? So the problem which you have just seen talks about a ring having charge lambda per unit length, right? Lambda coulombs per unit length per meter is a charge on this ring. The ring is placed in YZ plane, and its axis is along x-axis. Now there is a charge located at point P, whose coordinate is root 3 r comma 0 comma 0. Now this is wrongly put here. The charge is actually at point P. Now we have to project this charge with minimum velocity v so that it doesn't come back. Now why it will come back? It will come back because this is a positive charge and the ring also has a positive charge. So they will repel each other. Because if I project with much less velocity, what will happen? Its velocity suppose becomes 0 in between. Before crossing the ring itself, its velocity suppose becomes 0, then it will start gaining velocity backwards and it will again come back to its position. Now, one thing that immediately comes in our mind is what if I project with very high velocity so that it crosses the ring itself. Now, if it crosses the ring and it has some velocity still along the left hand side, then what will happen? It will go towards infinity. Then, of course, it is not coming back to point P. But we need to ask ourselves, is it the minimum velocity? Of course, there is no limit to the velocity. Once, if it is greater than 0, you can after that have any velocity for which velocity is greater than 0, it will reach infinity. But what if velocity is just 0 at the center? Now, if velocity is just 0 at the center and charge suppose reaches over here, right, with velocity equals to 0. Now, what is the force between this charge and the ring? The force between charge and the ring, due to the symmetry, you will see that is 0. Because if you take any point charge on the ring over here, it will try to push it this way. There will be a similar point charge sitting exactly opposite direction, which will push it in opposite way. So net everything get cancelled out. So there is no net force. So once charge reaches over here and its velocity is 0, it will remain there. So that is the minimum velocity. Now we got point number P and point number O. So charge should start from point P and reach point number O with 0 velocity. That is the minimum velocity. Now, how do I get the velocity? Now, one thing that immediately comes in our mind is conservation of energy. Now, conservation of energy says work done by the other forces is equal to U2 plus K2 minus U1 plus K1. Point number 1 is O and point number 2 is P. Now, what is this other force? This other force are the forces other than for which you have considered the potential energy. Because potential energy is generally considered for three forces. One is gravitation, other is electrostatic, and the third is spring. Now, in this case, there is no net change in gravitational potential energy. Whatever gravitational potential energy could be there at point number P is same as point number O. So, gravitational potential energy at point number 2 cancels out from point number 1. And of course, there is no spring potential energy. So, that leaves us with only electrostatic potential energy. And this work done by other forces is also 0 because there are no other forces. So 0 is equal to electrostatic potential energy at point number 2 plus kinetic energy at point number 2 minus potential energy at point number 1 plus kinetic energy. Now we have assumed that once it reaches point number O, its kinetic energy becomes 0. So K2 is also 0. Now, electrostatic potential energy is what? Electrostatic potential energy, we know between 2 point charges is K Q1 Q2 by distance between the point charges, right? Now, this is not a point charge. This is a circular charge with charge unit length lambda. But the good thing is that all the charges along this circle are equidistant from this charge, which is a point charge along axis wherever it is, right? So when I when I add up all the point charge, it will consider the whole circle automatically. So potential G at point number 2 should be equal to K charge on the ring, which is 2 pi r times lambda, into the second charge divided by distance between them, which is r, right? And potential G at point number 1 is equal to K 2 pi r times lambda into q divided by distance between them. What is the distance between all the point charges and all the point charges on the ring and this charge? It is actually this one, right? This is root 3a, root 3r, and this is r. So this is 2r from Pythagoras theorem. So u1e is this, and k1 kinetic energy, of course, there is no ambiguity. Kinetic energy is always half mv square. So once I substitute these values, I'll get the answer for velocity.